Hello and welcome back to Calculus 1. Section 5.4 on working with integrals. This is a very short section. It has few formulas that are practically quality of life improvement. And then that's it. First, I would like to review one thing, and that is that antiderivative, which we call integral, is supposed to undo the derivative. So if we have that the derivative of sine x is cosine x, then the integral of cosine x dx is sine x plus c. And this plus c was there because this could have been sine x plus 10 or minus pi or whatever, and the derivative would destroy that piece of information. So when you go back, you don't have any way of figuring out what that is unless you have what we call initial point, initial condition. So these type of integrals with the plus c are called indefinite integrals. And we have another type of integrals where you can compute the value. In 5.2 we learned about definite integrals. Which had limits. So let's say from -2 to 6 of, let's say, x dx, just to be lazy. So this is going to be x squared over 2. And now instead of putting plus c, we put computed from -2 to 6. And our fundamental theorem of calculus said that we plug the upper limit first. So that's 6 squared over 2 minus -2 squared over 2. And as you can see, we get a number at the end. So this is 36 divided by 2 is 18. Minus 4 divided by 2 is 2. For a total of 16. And then we said that this could give us an area if the function dips, if the function never dips below x-axis. Now, we learned a lot of formulas to deal with integration, and what follows now are just these few formulas that are quality of life improvement. For instance, even and odd functions. What we have is, let's say, a function that contains only even exponents of x. Say maybe you have f of x is equal to 3 plus 7x squared minus x to the 4th. Function like this would be even because it satisfies f of negative x is equal to f of x. So if you are to calculate f of negative x, you would see that it's the same as the original function. Plug in negative x for each x. When you square negative x, you just get x squared. When you put to the 4th power, you again get positive. So the function doesn't change if you replace x with negative x. So we say that then it's symmetric on the y-axis. And if it's symmetric on the y-axis for integrals, that has a big impact. Because if you have the symmetric interval from -a to a of f of x dx, where f of x is even, then you can simplify the formula, and instead of calculating from -a to a, you can calculate from 0 to a and double the integral. So it is a very interesting, I mean, it's clear when you draw the picture what's going on. if you have the function which is symmetric, like let's say a cosine function, right? This is cosine x, and you're looking for the area under the cosine function between negative pi over 2 and positive pi over 2. Hopefully you see that this area here is double than area there, right? So that's why the formula works. It exploits the symmetry on the y-axis, and then you can just compute the half. It's much easier to plug in 0 as your limit for calculating the negative a. Let's say negative 3 or negative 10 or negative ln 2. Right, it's much better to plug in 0. It's easier to plug in 0. So this formula is just a quality of life, right, formula. If you see that the function is even, so what else falls in the, so all of polynomials with even powers. If you have a mixture, even and odd, it's not even, it's neither in that case. So only allowed to have even powers for polynomials, and then you have also cosine and secant are also even. Then we have the next part where you have the odd function. Now, odd f of x is going to have property that f of negative x gives us negative f of x. So that's the pre-calculus property you learned in Calculus1, chapter 1. And for polynomials, that would be all odd exponents. You don't have to have all of them present. You can have any. So let's say you have 3x minus 9x to 11 plus 4x to 19. As you can see, I don't have x cubed, x to the 5th, x to the 6th. I don't have those. But the ones that I do have, they all have odd exponents. So that's odd function. Now, if you venture out of the realm of polynomials, you will actually have to apply the formula, the rule. So the rule is not there for decoration, right? You need to know the rule, and you looking at the all odd exponents here is just a shortcut, right? So that's a shortcut. So now what is the calculus quality of life improvement here? It says that from negative a to a, f of x dx is equal to 0. And that's if this is an odd function. It will save you a lot of calculation if you continue pushing engineering and math, and eventually you run into Fourier transforms and things like that. This thing, as you can see, you claim on the symmetric interval and its odd function, immediately you're done. You know, in some later classes when you have to expand things, no, if you can use any kind of shortcut, it's great. So that's even and odd functions. All you need to do is for even you, right? But now we have more for the lecture, obviously. The average value. Yeah. So for average value, we are going to calculate f average as 1 over b minus a integral a to b f of x dx. So this is your average value. Average value interval. So average value of the function. What do you mean average value of the function? Well, it's where it's like a half of area, right? The area above that line and the area below that line have the same amount. So let's go to homework. It says calculate the average value. So find the average no coughing value for what I say f of x equals 1 over 1 plus x squared on interval -1 to 1. Great. We integrate. So I have average value f is equal to 1 over b minus a. So this is 1 minus -1. Integral -1 to 1 of 1 over 1 plus x squared dx. So I hope you all agree that it's a half in front. What's the integral of 1 over 1 plus x squared? Nope. Tangent inverse. Stand and be recognized. Everyone bow. Yes, that's the inverse tangent. So, tangent inverse of x. And then we have to compute from -1 to 1. So we have 1/2 tangent inverse of 1 minus tangent inverse of -1. So now tangent inverse of 1 is pi over 4. And tangent inverse of -1, this negative jumps in front because it's an odd function, so it becomes another plus pi over 4, which creates pi over 2. Half of pi over 2 is pi over 4. Yeah, let's put a step in. 1/2 times pi over 2, which is again pi over 4. That's the average value, pi over 4. You draw the line, the horizontal line through y equals pi over 4. It splits the area evenly. All we need to do is to rename this formula now into the mean value theorem for integrals. So, mean value theorem for integrals. And that one says that f of c is equal to the f average, which is 1 over b minus a integral a to b of f of x dx. So this is our mean value theorem. And as you can see, it's I'll write it here in blue, I guess. Same as average formula. Done deal. Let's take a look at the word problem and then disappear into the night. Average height of a wave. A lot of waves in our existence. Not just the ocean, but the sound, the light, a lot of stuff is going to be earthquakes. Yep. So, yes. Now, what we have, guys, is the for earthquake, what I wanted to mention, the scale measures earthquakes, but you have the constant tremor of the surface that we evolved to tune out. So currently there is a shake because the core of the planet is spinning at a different rate. So the Earth is constantly shaking, but it's shaking ever so slightly. We evolved to not to feel that shake. But anytime you put that seismograph needle, it's very sensitive, right? That's just a piece of mechanical thing. That can't evolve to tune that out. We did. So we feel, you know, earthquakes 3 and above, right? Up to 3? Not really, right? And it's the constant tremor at 1, 1.5. That is all the time on. So we have now a wave, and this could be any kind of wave. It doesn't have to be, but I would like to say that this is some kind of ocean wave or something, because I can use 5 as a 5 feet, right, for the amplitude. So y equals 5, and I have 1 plus cosine x. 1 plus cosine x. So this wave would go 5 in amplitude. That means actually 10 feet between the lowest point and the highest point, because 5 is the amplitude. That's half of the wave. So this is my equation, and what we want to know is what's the average height from negative pi to positive pi. Now, what is this pi? Well, it's the distance, right? The distance going forward, and from negative pi to positive pi, you have 6 feet, right, of distance forward, and you are wondering what's happening with the distance going up and down. So what's the average height of this? Well, we integrate quickly. Our f of c is f bar, which is 1 over pi minus negative pi, integral from negative pi to pi of 5, 1 plus cosine x dx. And the cool thing is that we can use our improvement, right, quality of life improvement formulas. I have negative 1 over 2 pi, right, because pi plus pi. Why do I put negative? It's just 1. And now I'm going to kick this 5 out, so that's 5 over 2 pi. And note what I have, 1 plus cosine. Hey, that's even, right? Right. So I can have another 2, and then calculate from 0 to pi rather than negative pi to pi. And I still have my 1 plus cosine x dx to deal with. Now this 2 will cancel the 2, so it's just 5 over pi. Integral of 1 is x. Integral of cosine is, very good, computed from 0 to pi. So now 5 over pi, plug in pi everywhere. That's going to be pi plus sine pi minus 0 minus 0. And sine pi is also 0, so the average value is 5, which makes sense if you have a wave that is 10 feet tall, right, from the bottom to the top, to be in the middle at 5, right? Bye. Yeah, I know, time to pass out, exactly.